In the lesson 4.8 example, is this lottery fair to all pilots? We're going to find probabilities using combinations. In this problem, we have an airline that's just finished training 25 junior pilots. 15 of them are male and 10 are female. Unfortunately, we only have 8 captain positions available right now. So of those 25, only 8 of them are going to become captains of their own airplane. Airline managers announced that they're just going to do this randomly, that there's going to be a lottery process to determine which of the 25 pilots will fill the captain positions. We're going to put all 25 pilots' names on identical slips of paper, put them into a hat, mix thoroughly, and draw out one at a time until all 8 captains have been identified. The next day, the managers announced the results of the lottery, and of the 8 captains that were chosen, 5 of them are female, and only 3 are male. 5 of the 10 are female, and 3 of the 15 males were chosen for captains. Some of the male pilots who were not selected suspect that maybe the lottery was rigged, that maybe it wasn't carried out fairly, and that it was skewed in favor of the women. So what we want to do is in part A, want to find the number of different ways in which a fair lottery could have resulted in such a group. So we want the number of ways to choose 5 of the 10 females and the number of ways to choose 3 of the 15 males. And we're going to multiply them because these are independent decisions that we're making. So this is 10 choose 5 because there are 10 females from which we're going to choose 5. And all we're concerned about is the groupings, not the order in which they're selected, because the same 5 women might be selected a bunch of different ways. So we want the number of combinations that we could select 5 from 10 for the females, and the number of ways that we could select 3 from 15 for the males. These calculations are how we calculate these two things. 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. When you do the calculation here, you'll get a number. You'll get a different number here. 252 is the result for 10 choose 5. 15 choose 3. The result is 455. We're going to multiply those two numbers together and get 114,660 different ways in which you could get 5 female and 3 male pilots being selected from this group. Part B of the problem asks us to find the probability that a fair lottery would have resulted in a selection of such a group. So the probability that the result is 5 females and 3 males is going to be the number of ways that we could choose 5 females and 3 males out of the total number of ways we could have selected 8 pilots at all. So this is the answer from A, the 114,660 number. And now we need to figure out the total number of ways to select 8 pilots. Well, in this case, we're not going to look at the male-female business. We're just going to say, how many different ways could I select 8 from 25? That's calculated this way, and when simplified, gives us over 1 million different ways that we could have selected 8 pilots. And so we end up with this number, 114,660 over 1,081,575, which simplifies to about 10.6%. In part C of the problem, we want to know, based on our answer to B, is there convincing evidence that the lottery was rigged, that it wasn't carried out fairly? So what we noticed is there's about a 10% chance that fair lotteries would result in such a group of 5 female and 3 male pilots. This is not particularly unlikely. Had this been an incredibly rare event, we would have said, oh, now we have evidence of an unfair lottery. But we don't. This 10% chance is fairly high, so it's not particularly unlikely that the lottery was unfair. If you'd like to try a problem like this in your textbook, you can try exercise 9 in this section.